Hello everyone, this is Ajay and you are welcome on my YouTube channel which is Math Cafe. So this one is the part third of our topic which is matrix. So this video is all about types of square matrices. So we will be seeing some definitions based on types of square matrices, in which first definition is diagonal matrix. So first of all, we will see definition of diagonal matrix. A matrix is called diagonal matrix in which all the non-diagonal elements are 0, but not all the diagonal elements are 0. That means at least one diagonal element should be non-zero. So a matrix is called diagonal matrix in which all the non-diagonal elements are 0, but not all the diagonal elements are 0. That means at least one diagonal element should be non-zero. All right. So let's take an example. If a matrix is of n cross n order, then we can represent it as first element is d1 and and all the elements should be 0. And second element is d2 and all the non-diagonal elements are 0. Just like that, d3 and all the non-diagonal elements are 0. And same as last element is dn. So as we can see in this matrix that all the diagonal elements are d1, d2, d3 up to dn, right? So not all the diagonal elements are 0. This kind of matrix is called diagonal matrix, and we can represent it as diagonal of d1, d2, d3 up to dn. All right, let's take another example. All right, if a matrix is written in the form 1 0, let's say 0 and 2, so this is 2 cross 2 matrix. This is kind of a square matrix, and we can represent it as diagonal of 1, d1 is 1 and d2 is 2, so we can represent it as diagonal of 1 comma 2. All right, and let's take another example based on diagonal matrix. If I have a 3 cross 3 matrix 1 0 0 0 0 0 0 0 4. All right, so this is a 3 cross 3 matrix, and we can say that this is diagonal matrix because not all the diagonal elements are 0, but all the non-diagonal elements are 0. All the non-diagonal elements are we can see all the non-diagonal elements are 0, but not all the diagonal elements are 0, and we can represent it as diagonal matrix of 1 0 and 4. All right, so we can represent it as diagonal of all the diagonal elements which are 1 0 and 4. Hope you understand this. Let's take in another example. So it is written that in a diagonal matrix of in a diagonal matrix of order n, all right, we need to find first thing maximum number of zeros. All right, so let's take an example of a matrix whose order is n. So let's say a matrix of n cross n order is let's say d1, d2, d3 and up to dn, and all the non-diagonal elements are 0. All right, okay. So in this matrix we need to find maximum number of zeros, as we know that total number of elements in this matrix are n square. All right, so number of rows are n and number of columns are n, so total number of elements are n square, and we need to find maximum number of zeros. All right, so maximum number of zeros would be, so total elements are n square, in which we know that not all the diagonal elements can be 0. So we will take at least one non-zero diagonal element. Let's say d1 is non-zero and d2, d3 and up to dn can be 0. So one element will be non-zero, so I will subtract in total number of elements. So n square minus 1 will be maximum number of zeros. All right, hope you understand this. Let's take another example b. If we need to find minimum number of zeros, we need to obtain minimum number of zeros. If we need to obtain minimum number of zeros, and then I will take all the diagonal elements as non-zero. So 0 elements will be only non-diagonal elements. So if total number of elements are n square, then I will subtract all the non-zero diagonal elements, that is n. So n square minus n would be minimum number of zeros. All right, so let's see the third part of this question. If it is asked that maximum number of distinct elements, maximum number of distinct elements. So take some time and answer this question. So we know that in maximum case of distinct elements, I can take all the diagonal elements distinct. All right, so n these are distinct diagonal elements, and as we know that in the diagonal matrix all the non-diagonal elements will be 0. So d1, d2, dn are non-zero distinct elements. So I can say that all the maximum distinct diagonal elements could be n, and the another number, that is 0, that are non-diagonal elements. So total number of maximum distinct elements would be n plus 1. All right, hope you understand this. Let's take another example of this question. If it is asked at minimum number of distinct elements, minimum number of distinct elements, as we know that all the non-diagonal elements are 0. So in the minimum case I can take except one diagonal element, I can take all the diagonal elements 0. So if d1, d2 up to dn minus 1 are 0, then distinct and dn is non-zero. All right, so number of distinct element will be 0 and non-zero number. So number of distinct element would be 2. Hope you understand this. Another part, that is scalar matrix. So first of all, we will see definition of scalar matrix. In any diagonal matrix, if all the diagonal elements are same, then this type of matrix would be called scalar matrix. All right, so in any diagonal matrix, if all the diagonal elements are same, but if all the diagonal elements are same but they cannot be 0, and equal to a non-zero quantity. All right. In mathematically, if I represent it as if any matrix is diagonal of d1, d2, d3 up to dn. This is a kind of diagonal matrix of n order. So in this matrix, if I put d1 equal to d2 equal to d3 is equal to dn equal to a constant number k, which is not 0, then this type of matrix will be called scalar matrix. All right, so let's take an example. If any matrix is represented by 3 0 0 3, so this is 2 cross 2 diagonal matrix, but this is a scalar matrix because all the diagonal elements are same and non-zero. So this is a scalar matrix. Let's take another example of scalar matrix. If any matrix A is represented by 10 0 0 0 10 0 0 0 10, as we can see that this is a diagonal matrix because except all the diagonal elements, all the non-diagonal elements are 0. All right, this is a special type of diagonal matrix which will be called scalar matrix because all the diagonal elements are same. All right, hope you understand this. Identity matrix. Any scalar matrix if all the elements are equal to 1, all the diagonal elements are equal to 1. So what will be called an identity matrix? In any scalar matrix, if all the diagonal elements are equal to 1, then this kind of matrix will be called identity matrix. Or I can say that in any diagonal matrix, if all the diagonal elements are same and equal to 1 and is equal to 1, that kind of matrix will be called diagonal matrix. All right. So in any diagonal matrix, if all the diagonal elements are same and is equal to 1. All right, so this kind of matrix will be called identity matrix. So if any diagonal matrix is represented by diagonal of d1 d2 up to dn. All right, in this matrix if I am putting d1 equal to d2 equal to d3 equal to dn equal to 1, then this type of matrix will be called identity matrix. So let's take an example here. If I am taking any matrix I which is 1, so there is only one element, so this type of matrix will be called identity matrix and order of this matrix is 1 cross 1, and this will be represented by I1 and another matrix I2 1 0 0 1. All right, so all the diagonal elements are same and non-diagonal elements are 0, so this type of matrix will be called identity matrix and 2 cross 2 and order will be 2 cross 2, so this type of matrix will be represented by I2. Let's take another example. I3 1 0 0 0 1 0 0 0 1. So this is also called identity matrix of order 3 cross 3. Hope you understand this. So let's take an example here. So the example is in a matrix In find total number of zeros. As we can see that I1 is represented a matrix of order 1 cross 1, I2 is represented by a matrix of order 2 cross 2, and I3 is represented by an identity matrix of order 3 cross 3. Then In will be represented by an identity matrix of order n. Alright, so In will be represented by 1 0 0 0 0 1 0 0 0 and 0 0 1 0 0 0 0 and 1 in the last. All right, so this is an identity matrix in which all the diagonal elements are same and is equal to 1. All right, so in this matrix we need to obtain total number of zeros. So as we know that in this matrix only non-diagonal elements are zeros, so total number of zeros would be all the non-diagonal elements, and total number of elements are n square minus all the diagonal elements are n. So these are total non-diagonal elements. So n square minus n would be total number of zeros in IN. Hope you understand this. So next type of matrix is triangular matrix. There are two types of triangular matrix. First one is upper triangular matrix. And second one is lower triangular matrix. So first of all, we will talk about only upper triangular matrix. So definition of upper triangular matrix is if any matrix capital A is represented by Aij n cross n. All right, order of this matrix is n. If in this matrix, if I put a condition that if all the elements Aij will be 0 if I is greater than j, all right, then this type of matrix will be called upper triangular matrix. But we haven't said anything about diagonal elements, so all the diagonal elements should be non-zero. So let's take an example here. If any matrix A is A11, A12, A13, A21, A22, A23, A31, A32, A33. Alright, please pay attention that all the elements Aij would be 0 if I is greater than j. In this A11 I is equal to j, in this A12 I is less than j, A13 I is less than j. In this A21 I is greater than j. Alright, so this element should be 0. A22 I is equal to j, A23 2 is less than 3, that means I is less than j. Alright, so that would be non-zero. In this element A31, so I is greater than j, that means this element should be 0 if this is a upper triangular matrix. A32 I is greater than j, then that means this should be 0. And A33, that means I is equal to j, this cannot be equal to 0. So if a matrix of order 3 cross 3, this is a upper triangular matrix, then A21, A31 and A32 should be 0. I can say it as all the elements lying below the diagonal element should be 0. So this matrix A is being upper triangular matrix, then all the elements A21, A31, A32 should be 0. So let's take an example here. If I'm representing a matrix as 1 5 0 2, all right, so this matrix will be called upper triangular matrix, in which all the elements lying below diagonal should be 0. So 0 is lying below this diagonal, so this triangular matrix is called upper triangular matrix. Hope you understand this. Let's take another example here. If any matrix B is represented by 1 2 3, let's say 0 5 7 0 0 and 3, as you can see that all the elements lying below the diagonal are 0, then this type of matrix will be called upper triangular matrix. All right, so let's see the another part of this triangular matrix, that is lower triangular matrix. So second part is lower triangular matrix. if any matrix A is represented by Aij, alright, so Aij would be 0, all the elements Aij would be 0 if I put a condition that all the I less than j. Alright, for I is less than j, all the elements Aij would be 0. That this kind of matrix would be called lower triangular matrix. Alright, so let's take an example here. If I'm taking an example, if any matrix A is represented by let's say 3 0 5 9. So this one is A11, this one is A12, this one I should mention this A11, A12, this one is A21, and this one is A22. So all the elements for which I is less than j, here I is equal to j, here I is less than j. So for I is less than j, element should be 0. So here as we can see that this is 0, and here I is greater than j, and here is I is equal to j. So this type of matrix would be called lower triangular matrix. Lower triangular matrix. We can also understand it as if all the elements lying upper side of diagonal that are 0, that will be called a lower triangular matrix. So let's see another example here. If any matrix B is represented by, let's say 1 0 0 2 3 0 minus 1 2 and 1. So as we can see that all the elements lying upper side of this diagonal are 0, then this type of matrix will be called lower triangular matrix. Okay, let's take an example here. If in any upper triangular matrix of order n, if in any upper triangular matrix of order n, we need to obtain first maximum number of zeros. Maximum number of zeros. So as we can see, this matrix is upper triangular matrix of order n. So let's assume it as this is upper triangular matrix. So all the elements lying below the diagonal should be 0. So let's assume it as these are all the diagonal elements, and the all non-diagonal elements lying upper side should be non-zero, and lying on lower side should be 0. All right. So in this matrix we need to obtain maximum number of zeros. So these are all the elements zeros. So we need to find number of these elements. Order of n cross n matrix, then all the non-diagonal element would be n square minus my n. But we need to find all the elements which are lying below the diagonal. So I will divide the whole number by 2, because all the elements lying above the diagonal and below the diagonal are same. Let's take another part of this question. If it is asked in the B part that find total number of maximum distinct elements. Find total number of maximum distinct elements. All right. So let's take this matrix. As we need to obtain the total number of maximum distinct elements, so I can put all the diagonal elements as distinct. All right, so I'm putting all the diagonal elements as distinct. So total number of elements, diagonal elements, are n. If I'm taking all these numbers lying upper side of diagonals as distinct, so these numbers are n square minus n divided by 2, n square minus n divided by 2. So these are all non-diagonal elements lying upper side of diagonal. All right, so what about the lower side of diagonal? As we know that all the elements lying lower side of diagonals are 0. So total number of distinct element is only 1. All right, so this would be the answer for this question. Hope you understand this lecture. If you have any doubt regarding this lecture, please ask me in the comment section. See you soon in the next video. Till then, bye, take care and keep learning.